Good morning, student. Today we are going to learn about quantization. After the completion of today's session, you are able to define quantization, classify the quantization, and define quantization of error and noise. So, for conversion of analog to digital signal, the essential operations are sampling, quantizing, and encoding. So, quantizing is the second essential operation for conversion of analog signal to digital. Quantization refers to the process of approximating the continuous set of values with a finite state of values. The input to a quantizer is the original data and the output is always one among a finite number of levels. The analog to digital converter performs this type of function, that is quantization, to create a series of digital values out of the analog signal. Means in the first step, means in sampling step, the continuous time signal is converted to discrete time signal. Means from the continuous signal we get our samples. Then in quantization step we compare that samples with a predefined levels. Okay. The quantizing of an analog signal is done by discretizing the signal with a number of quantization level, that is predefined levels. Okay. Samples taken are assigned numeric values that the digital circuit can use in a process called quantization. When a sample is quantized, the instantaneous value of its analog amplitude has to be rounded off to the nearest available digital value. This rounding off process is called approximation. So, here you can see. In the first step in this diagram, the continuous time signal is converted to samples. Then these samples are placed in a predefined levels or compared with predefined levels. Means this one means 1 2 3 4 means these are the levels. This is the 1, this one 2 3 4, these are the predefined levels. Okay, we compare our samples with that levels. So see here, this one is the first sample. Okay, we compare with the level and get the value 4. Then second sample is here. This sample is present in between 6 and 5. Means maybe it is 5.8. So we have to round it off the value to 6. Because of that, this step is increased and here it is given. Means the signal is drawn like a step after approximation. Means here we just rounded the value to its nearest value. Okay, if we have actual value of 5.8, then we rounded off to its nearest value, means to 6. Like this. Here this one, this sample is the value of this sample is in between 4 to 5. So maybe it is 4.7. So we just rounded off to the nearest value, means it is here 5. So we take the value of 5 and then again go to the next step. So this process is known as rounding off process and we can say it as approximation. This rounding off process is called approximation. So first we convert the signal to samples, then we compare that sample with some predefined levels, and from that comparing we get some exact value. Means if it is 1 2 3 4, then okay. If the value is like 1.1, then we round it off to 1. If it is 2.8, then we round it off to 3. Like this we get some exact number. Means we cannot represent a value like 1.8 in a binary format, so we have to rounded it to 2 so that we can convert the 2 into its binary value. Okay, so rounded off process is necessary because of that only. Okay, next, the spacing between two adjacent representation level is called the step size. And what is that representation level? The discrete amplitude of the quantized output are called as representation level. So these are the steps. Okay, here these are the step size, which is generally denoted as delta. Okay, next, types of quantization. There are two types of quantization: uniform quantization and non-uniform quantization. A quantizer can be specified by its input partitions and output levels. If the input range is divided into levels of equal spacing, then the quantizer is termed as a uniform quantizer, and the quantization obtained by a uniform quantizer is known as uniform quantization. And if the spacing is not equal, then it is termed as a non-uniform quantizer, and the non-uniform quantizer gives non-uniform quantization. So here you can see two diagrams or two graphs. First one is the uniform quantization, second one is the non-uniform quantization. In the diagram you can see here the step size are equal in each case. So if the step size is constant or fixed, then that is known as uniform quantization. But in second diagram you can observe that the step size are not equal. Means here it is smaller than these step sizes. So when the step size is variable, means not constant, as per requirement it varies, that quantization is known as non-uniform quantization. Okay, next is the types of uniform quantization. Means the uniform quantization again divided into two types, that is mid-rise type uniform quantization, and second one is mid-trade type uniform quantization. So the mid-rise type is so called because the origin lies in the middle of a rising part of the staircase. So see here, if this one is the origin line, then the staircase is like this. Means this one is the positive half, this one is the negative half. This is the origin, and here the rising part of the staircase in positive side, and here is the rising part of the staircase in the negative side. So in between these two rising part the origin is present. Because of that this is known as mid-rise type. Okay, second one is the mid-trade type. The mid-trade type is so called because the origin lies in the middle of a trade of the staircase. So if this one is the origin line, then here is one trade, then here is the complete staircase, this one, then here is the positive part, and here the y-axis. Okay, so origin is in between a trade of a staircase. Okay, means if this one is the complete staircase, the origin is present in between this line, means this line is known as trade in between this line. Because of that, this is known as mid trade type uniform quantization. Next is the quantization error. For any system, during its functioning, there is always a difference in the values of its input and output. The processing of the system results in an error, which is the difference of those values. Okay, means here you can see here the actual sample, one second, here this one, here the actual sample is in between 4 and 5, maybe it is 4.4. okay, so we just round that value to 4, means actual value is 4.4 minus 4, means 0.4 is the difference. So that difference is the quantization error. When we rounded off the value, actual value minus the approximate value, the difference between these two values is the quantization error. So the difference between an input value and its quantized value is called a quantization error. Then another term is known as quantization noise. It is a type of quantization error which usually occurs in an analog audio signal while quantizing it to digital. For example, in music, the signals keep changing continuously, where regularity is not found in errors. Such errors create a wideband noise called as quantization noise. So this is all about quantization. Thank you.